This problem says Jessica left the movie theater and traveled toward the Capitol. 2 hours later, Darryl left, traveling 28 kilometers per hour faster in an effort to catch up to her. After 3 hours, Darryl finally caught up. What was Jessica's average speed? So, when we're doing a problem like this that includes times and rates, um, and we're looking for like speed being the same thing as rate, let's use the equation distance is equal to rate times time. So this is distance The R represents rate, also known as speed, like how fast you're traveling. And then the T represents the time. So I think this problem is, it's helpful to set up like what happens with Jessica versus what happens with Darryl, like in separate regions. So let's do Darryl on this side and Jessica, information with Jessica on this side. So for Darryl, if we use our equation, distance is equal to rate times time, let's see what do we know out of these things from the information given in the problem. Well, we know that Darryl is traveling 28 kilometers faster than Jessica. So if we say that Darryl's rate, the rate of Darryl, is equal to the rate of Jessica plus 28. That gives us one relationship between Darryl's rate and Jessica's rate. Also, it says that Darryl left 2 hours later than Jessica, and after 3 hours, Darryl caught up. We can assume that Darryl's time is 3 hours, because it says after 3 hours, Darryl finally caught up. So, how do we use this information? Well, let's plug it into our equation, distance is equal to rate times time. So, Darryl's distance is equal to Darryl's rate, which we made a little expression of Darryl's rate to be Jessica's rate plus 28. And let's multiply that by Darryl's time, which is 3 hours. Okay, so if we simplify this a bit, we get that Darryl's distance is equal to, distributing the 3 to make 3 times Jessica's rate plus 3 times 28 is, let me grab my calculator, 3 times 28 is 84. And by the way, because our rate is given in kilometers per hour and our time is given in hours, that means our distance is in kilometers. We don't necessarily need to know that for this problem because they did give us units that cancel out without converting, but just to keep that in mind. Okay, now let's think about the relationship between the distance that Darryl traveled and the distance that Jessica traveled. They both left the movie theater and went to the Capitol. So that means that the distances they travel would be equal to each other. So when we want to say Jessica's distance, what is that equal to in terms of Darryl's distance? It's going to be equal to Darryl's distance. So since those two are equal, when we do the distance equals rate times time equation for Jessica, we can plug what we found for the distance for Darryl into distance for Jessica because those two things are equal. So 3 times Jessica's rate plus 84 is the distance that Jessica travels. that's equal to the rate that Jessica travels, which we already defined as RJ, times the time that Jessica traveled. Well, how long did it take for Jessica to travel? Well, Jessica left. 2 hours after Jessica left, Darryl left, and Darryl spent 3 hours catching up to her. So, in the time that Jessica traveled by herself is 2 hours, and then Darryl and Jessica traveling together is another 3 hours. So that's a total of 5 hours that Jessica traveled. Okay, and we're assuming that that they traveled towards the capital and they met at the capital at the same time. Well, I guess it doesn't have to be at the capital, but they met together, so they traveled the same amount of distance. Okay, so now we have this equation that only has the rate that Jessica's traveling as its only variable. So let's simplify just a little bit by writing the 5 in front. So 3RJ plus 84 is equal to 5RJ. And subtract 3RJ on both sides. So now we're doing some algebra here to get the variable by itself. Because the 3RJ minus 3RJ cancels out, leaving us with 84 is equal to, subtracting these because they're like terms, we can subtract their coefficients. 5 minus 3 is 2, so it makes 2 times the rate of Jessica. And then finally, we want to get the rate of Jessica by itself, so we divide both sides by the coefficient, and 84 divided by 2 is 42. So Jessica's rate is 42, and that would be in a unit of kilometers per hour. And the question is asking for what is Jessica's average speed. This would be like, she obviously isn't going to go this speed the entire time, but on average, she'll be traveling 42 kilometers an hour if Darryl is traveling on average 28 kilometers an hour faster than her to catch up with her. Okay, well, I hope this homework help problem was helpful for you. If it was, please leave me a like and subscribe to my channel for more homework help videos. Also, if you have any questions that you would like answered, you can feel free to leave those in the comments. Also, I have my email down in the description that if you can't leave it if it's too big of a question to leave in the comments, feel free to send me an email and I'll do my best to make a video for your problem. Thanks for watching.